Hello everyone and welcome to my seminar on special topics in emerging areas. So before starting, let me give a brief introduction about myself and my university. So my name is Tanishq Kohli and I'm a third year student at Bennett University currently pursuing computer science engineering. Bennett University is a Times Gov initiative in Greater Noida, Uttar Pradesh, which was founded in 2016. It has 5 total schools, namely the School of Engineering and Applied Sciences, the School of Law, the School of Management, the School of Mass Media and Communication, and finally the School of Liberal Arts. So thank you to Bennett University for providing me an opportunity to conduct a seminar on my topic of choice. So let's move on to that now. So my topic of choice is the James Webb Space Telescope, and I hope that by the end of the session you'll have a basic understanding of how it operates and why it was needed in the first place. So let's begin. So first let's talk about what makes the James Webb Space Telescope. So it is made of 18 hexagonal mirrors which are entirely made of gold, and the focus is calibrated by shifting the mirrors to 1/10,000th of the thickness of a human hair. So that's how precise the focus is. And the telescope is equipped with 4 major tools, which are near cam, near spec, the fine guidance sensor, and MIRI. And it also has a sun shield to protect itself from the reflected heat, which is made up of 5 layers with the vacuum in between. And all of that needs to be foldable so that it can actually fit inside the rocket, which will carry it to space. So first let's talk about near cam. So it is basically the primary image of the telescope in the near infrared range, and it is made up of 10 sensitive detectors. It is also equipped with a coronagraph. So what a coronagraph basically is that imagine yourself driving on a dark road and suddenly a car comes in front of you with light. So if you try and block the light if you try and block the bright light with your hands, you'll notice that you'll be able to see surrounding area more clearly. That is because your hands are blocking the main source of light, which is bright, so you're able to see the faintly lit objects well. That's exactly what a coronagraph does, but in space. So it blocks the brighter light so that we're able to see the faintly lit stars, galaxies, and planets. But the one major drawback of the near cam is that it can't tell us about the physical properties of the planets. Which brings us to the next tool, which is the near spec. So near spec studies the spectrum of light an object emits. So how it helps us is that by studying that, we can determine an object's mass, temperature, and its chemical composition. So how it will help us is that, let's say we are trying to observe a planet. So using spectroscopy, we can determine how heavy the planet is, whether it has a habitable temperature, and if it has the necessary chemicals for life to exist. So usually for a single spectroscopy to take place, the telescope would need to point at an object for over 100 hours, which is a long time, about 4 days. So scientists couldn't afford that. So what NearSpec actually does is that it can help provide spectroscopies of hundreds of objects all at once. And what helps it accomplish it are the 250,000 micro shutters that open and close and which block the irrelevant light. So now let's move on to the fine guidance sensor. So as you know, there's a lot of light in outer space coming from stars, planets, and even galaxies. And not necessarily all of that is useful for us. So the telescope only needs to point at relevant targets. So what it does is that it helps the telescope point at different directions constantly. And now let's move on to the final tool, which is MIRI. As you know, there are enormous amounts of thick dust clouds in outer space which block a lot of light. And so if the light cannot reach us, it is not helpful for us at all, and we cannot observe that part of space. So what MIRI does to go around that is that it only targets infrared radiation of longer wavelengths which can easily penetrate those dust clouds. So that helps in observing the redshifted light coming from far away galaxies. And I'll come back to redshifting in a bit. So a drawback of MIRI is that it needs to be cooled down to my negative 266.5 degrees Celsius or 6.7 Kelvin. And to help with that, scientists developed a cryocooler, which basically pumps in helium gas through pipes to cool MIRI down. But that's not all the heat in outer space. So the 3 major sources of heat that the telescope would need to block are the sun, the earth, and the moon. And to do that, the scientists developed a sun shield which is 21 meters long and 14 meters wide. It is made up of 5 layers with space between each layer to cool it down efficiently. And the layers are made up of a material called Captain, which basically is a special film that can withstand very high temperatures. And in order to block the heat efficiently, the telescope needs to be very far away from the Earth. And that distance is approximately 1.5 million kilometers. For reference, the Hubble Space Telescope is just 547 kilometers away from the Earth. So now let's talk about why we actually need a space telescope when there are already working telescopes right here on Earth. So the problem with telescopes on Earth is that they face 3 major problems, which are bad weather, light pollution, and atmospheric interference. And so telescopes in space can ignore all of those problems and thus are much better for space exploration. So now you must be wondering, why is there a need of a new telescope when we already have Hubble? Well, there are two major reasons. The first one of them being the size. So the James Webb Telescope is much bigger than the Hubble Space Telescope. So the Hubble Space Telescope was around the size of a school bus. The James Webb Telescope is the size of an entire tennis court. But the actual size of the telescope isn't actually a key factor. The key factor is the size of the mirror, because the bigger the mirror, the more light it can collect, and so astronomers can see farther away into the past. So to be precise, the James Webb Telescope is around 6 times bigger than the Hubble Space Telescope. So Hubble could see around 400 million years after the Big Bang happened, and scientists predict that the James Webb Space Telescope will be able to see around 250 million years after the Big Bang. And now let's move on to the second big difference, which is that the James Webb Telescope can detect infrared light. So the Hubble Space Telescope, as you can see in the image, could detect ultraviolet radiation, all of visible light, and some of infrared radiation. And the James Webb Telescope can detect much more of infrared radiation, which is also thanks to the gold-plated mirrors it has. So gold is an excellent reflector of infrared radiation, which is why the mirrors of the James Webb Telescope were made entirely of gold. And the reason why infrared radiation is better for space exploration is because of redshift. So let me now explain what redshift is. As we know, the universe is expanding at an accelerated rate. As the universe expands, the space between 2 points A and B also expands. And so the light coming from point A to point B also stretches. So as the light stretches, the wavelength becomes longer and it moves towards the infrared spectrum. So here's a video demonstration of how redshift actually occurs in space. So as you can see, the space is expanding between the galaxy and the Earth. So the wavelength of the light coming from the galaxy expands and it becomes red. And the experiment scientists have done also back this up. So here's an image comparing the light captured from a visible spectrum and an infrared spectrum. And as you can see, the infrared spectrum could capture more of the stars and more of the light coming from stars and planets, compared to the visible light, which has a lot of dust clouds. And so scientists like Michio Kaku believe that the James Webb Telescope will help us expand our understanding of the universe and might also help us come in contact with alien civilizations, as we'll be observing much more of space now. And so the telescope will help tell us about the births of galaxies, stars, planets, and also civilizations, and thus would help expand our understanding of the universe. So thank you for your time, and I hope I was able to help you understand more about the James Webb Telescope and how it will help us going ahead.